This is part 2 of section 9.4, multiplying special cases. Again, we're still looking at binomials today. So multiplying special cases of binomials. Part 1 was multiplying squares or squaring binomials. And this next part is called the difference of squares. Just little vocab there. We have the difference of something. Difference meaning subtraction. We'll see how that comes into play. And then squares. We still have something similar to a square. Now, the difference of squares is going to help us when we have the product of the sum and difference of the same two terms. So what that means is we have A and B, just like before, but this time one is addition and one is subtraction. So A plus B and A minus B. It's not really a square because they're not the same operation, but it does act similarly. So if we were to use FOIL, our method, and you can see this is played out on page 514 at the beginning of that second part. If we were to use FOIL, just like in the last case, we would take the product of the firsts, which is A and A times A, similar so far. The outsides, A, and in this case, when we're using FOIL, remember, we have to take into account that negative. A times negative B. So A times negative B. And then we have the insides, which is positive B and positive A. B times A. And then finally, positive B times negative B. Ooh, that's the lasts. And we can simplify each of these just like before, but we do get a little bit different answer. A times A simplifies to A squared. A times negative B, we actually subtract that term, A times B. Just like before, again, we have B times A, but we can rewrite that, the product, as A times B. And then finally, we have B times negative B is the opposite of B squared, or negative B squared. Like before, we have now like terms, but in this case, we have negative 1AB and positive 1AB. When we combine these, we are left with just 0. We don't have to write plus 0, so we can just write this as A squared minus B squared. This is where our name comes from, the difference of squares. A plus B times A minus B gives us the first term squared minus the second term squared. So that is going to be our rule for the difference of squares, just like we had for squaring something. Anytime we have A plus B times A minus B, we can jump right to the answer is the first term squared minus the second term squared. So let's try an example. This is example 4 in your book, if you're following along. And we have t to the third plus 6. Oh, I got that backwards. T to the third minus 6, excuse me, times t to the third plus 6. Now, I'm being particular. I wrote that with the sum first instead of the difference first because I want to ask the question, does it matter whether this subtraction comes first or addition comes first? Does this follow the same rule? And the answer is yes. We can still use the difference of squares. Why? Because this is a product. I could switch those two binomials around and it would be the same thing. It still follows the commutative property of multiplication. Now, I can use the same rule and say the first term is still the first term, even if the subtraction comes first. And so we have the first term, t to the third, squared minus the second term, which is 6 squared. One last step is I can simplify this. Again, remembering our rules of powers. A power to a power, we multiply the exponents. So this is t to the 6th power minus 6 squared is 36. So it'd be a good chance to try a quick check again on page 514. Quick check 4. You could try both A and C. Take a second to pause your video, try those. I'll put the answers up afterwards. Okay, our answers for A. A was D plus 11 times D minus 11. And when we find the difference of squares, that is D squared minus 121. And C, if you need to pause and try that one now, C was 9v to the third plus w to the fourth times 9v to the third minus w to the fourth. And when I take the difference of squares, get 81v to the sixth. This uses two products of exponents where we have a product to a power and a power to a power. So make sure you keep track of both of those. Minus w to the eighth. Again, this uses our power to a power and we multiply the exponents. If you have any questions, please feel free to see me during office hours. The practice for this section 9.4 will be available is available on RenWeb and the weekend preview. Make sure you check your answers before you send them to me. Thanks and have a great day, guys.